Welcome back, everybody. In this lesson we're going to be talking about different types of polygons, classifying them, a little bit of computation, but the main point is identifying polygons and the different types. Polygon, first of all, is an enclosed figure. That means you have three or more line segments connected together to form a figure. And probably the most basic one that comes to mind is a triangle right here. If we add another side, we would get a quadrilateral, four-sided figure. And then if you add another side, you get a five-sided figure known as a pentagon. Six-sided figure is a hexagon. Seven sides, known as a septagon, also sometimes called a heptagon, but mainly septagon. Think of a stop sign, you think of an eight-sided figure, octagon. And then they just go up from there. After 8, of course, you get 9-sided figures known as a nonagon, 10-sided figure, decagon, and a 12-sided figure is called a dodecagon. So those are your basic shapes and basic polygons from 3 sides all the way up to 12 sides. Now here we're just going to identify polygons. I'm going to put a green check by 3 of these figures. 3 of these figures are polygons. This figure here, figure A is a polygon. Figure B is a polygon. Figure D is a polygon. Now, figure C is not going to be a polygon. Notice the curved sides here. If you have a curvy side, that is not going to qualify as a polygon. Polygon needs to be made of straight sides. Figure C does not count as a polygon. Now here we have a quadrilateral. It says the interior angles formed by the sides of quadrilateral have measures that sum to 360. Now opposed to a triangle, remember, has 180, but a quadrilateral 360. Question here, what's the value of x? Well, what we're going to do is take all of those angles and the expressions for them. We have the 3x minus 6, we have the 2x, we have an 88, and we have a 108. So what we'll do is set that equal to 360 and use that to find the value of x. Let's first put together the 3x and the 2x to get 5x. And notice we have a minus 6, a plus 88, and a plus 108. If we put together the negative 6, the 88, and the 108, we're going to get a 190. And now we're going to about solving this two-step equation to get x by itself. First thing we're going to do is subtract 190 from both sides. And punch in the calculator. With 360 minus 190, we get 170. I still have the 5x. In order to get x by itself, we will divide 5 on both sides. That'll give us x by itself. 170 divided by 5, we get 34. So the value of x is 34. Again, what we did, we took all these angle measures and all the expressions therein, set them equal to 360 because a quadrilateral adds up to 360, and solve the resulting equation. All right, let's go back to our polygons. Now the whole idea of a regular polygon, when you see that, a regular polygon means all the sides are the same. That's what we mean by regular. And if we look at figure B here, all of those sides appear to be the same length. As opposed to all the others, notice they have different sides with different lengths. Angles, triangle C here, different sides. Figure D here, the two opposing sides appear to be the same on the opposite sides, but not all 4 of them. So that's why figure B. Figure B is the only one with every single side the same. That pentagon is called a regular pentagon. And then let's looking at these, we'll classify them. That first figure, 1, 2, 3, 4, 5 sides, pentagon. The middle figure, 1, 2, 3, 4, 5, 6, 7, 8, 8 sides, octagon. And this one, 1, 2, 3, 4, 5, 6, 7, call that a heptagon. Sometimes they call it a septagon. Hepta, septa, meaning 7 sides. So make sure you count and see the number of sides so we know how to name the figure. That's it for this lesson. Thank you very much for watching.